Good morning, ma'am. The title of our engineering explosion course project is Hexapod. Hexapod means a six-legged robot. This is Team 5 from O Division. We are four members in this team, namely Vikram, Namrita, Asif, Manvi, under the guidance of Mrs. Jyoti Gadad. Problem definition: the robot should be semi automatic. The robot should be able to move and cover itself in sand. The robot should be operated by a rechargeable battery. The robot should be operated wireless and it should appear as a reptile. It should be able to detect obstacles within 20 to 30 centimeters. It should not be heavier than 2 kg and about 30 centimeters long. The cost should not exceed about 3000 rupees. Function tree. In function tree, there are three main functions. First is dwelling. It should be able to dwell through sand. Second is sensing. It should be able to detect obstacles. Third is movement. It should be able to move forward and backward. Function cluster. There are three main subsystems in function cluster. First is dwelling system. It should be able to move and cover itself in sand. Second is sensing system. It should be able to detect obstacles within 20 to 30 centimeters. Third is movement system. It should be able to move forward and backward. Subsystem identified. We have identified four subsystems. First is movement unit. It is responsible for forward movement. Second is sensing unit. It is responsible for sensing the obstacle. Third is indicating unit. It is responsible for indicating the presence of obstacle. Fourth is concealing unit. It is responsible for digging of sand.
Generated concepts. So here are the four designs. First design is Raso. Raso uses Baffle's bucket drum for the locomotion. During loading, the bucket drums excavate soil by scoops mounted on the drum's exterior. Design 2 is FlipperBot. FlipperBot has been designed to test how real-life organisms such as sea turtles use flippers and fins to move on the surfaces such as sand. In this model, there are two flippers and tail which help in the movement and concealment through sand. Design 3 is Hexapod. It works mainly on the principle of the pterodynamics. Pterodynamics is the study of forces and movement during terrestrial locomotion on the ground. Here C-shaped legs are used for the locomotion. Design 4 is six-wheeled robot. Six-wheeled robot moves up a steep incline of sand. Tires are used for the locomotion and IR sensor is used for sensing obstacle. So the selected concept is design 3. Here C-shaped legs are beneficial for the locomotion. Based on the semi-automation, battery-powered indicator to signify presence of obstacle and resemblance of reptile, we opt for this design. Virtual implementation. This is the 3D model of the entire system. Let us have a look on the subparts. This is ultrasonic sensor which is used to detect the obstacle. The module includes ultrasonic transmitter, receiver and circuit. And here the limit for the sensing of obstacle is 20 centimeter. And the next is the Arduino Mega 2560 board where the program will be uploaded and based on those instructions the model is going to work. The next is C-shaped arms. This C-shaped legs which helps in the movement and these C-shaped legs are of 7 cm radius. There is hole at one end of it for the attachment purpose. Now let us have a look on the body of the model. Here we are using the foam sheet as a chassis whose length is 26 cm and breadth is 20 cm and thickness of 8 cm. And acrylic sheet is used for the housing. 6 DC motors are placed on the chassis with the help of the motor clamp. 3 motors are placed on the right edge and 3 on the left edge which are parallel to each other. Here, L clamps are used for attaching purpose. With the help of the wires, DC motors will be connected to the relay and Arduino for its working. And ultrasonic sensor is placed at the anterior part of the model. 6 six C-shaped legs, which are used for the locomotion, are attached to the shaft of the DC motor. There will be the difference of 8 cm between shafts of two DC motors because the movement of one C-shaped arm should not interrupt the movement of the other. C-shaped legs can make forward as well as backward direction based on the clockwise and anti-clockwise rotation of the DC motors. This is how the movement of module takes place. With the help of ultrasonic sensor, if the obstacle is detected within 20 cm, the model has to stop its movement and LED light glows indicating the presence of obstacle. If there is no obstacle, the model can continue to move in the forward.
Next, we move on to the circuit diagram of the entire system. Clearly, we can see that we have used 6 DC motors and 3 relay modules. Since one relay module connects to 2 DC motors, we have had to use 3. And we assemble the connections using a breadboard. And lastly, we have an ultrasonic sensor to calculate the distance between the obstruction and our bot. Moving on, we have the flowchart for the entire subsystem. So we first start, we turn our bot on, and it is supposed to be moving in forward direction. Next, if it detects an obstacle, there are two scenarios. If the distance between the object and between our bot and the object is greater than 20 centimeters, it will continue to move forward. But the second the distance becomes less than 20 centimeters, the bot will come to a stop. Next, we have the bill of materials. It is basically a list of all the components that we used while building our bot, and it begins with 6 DC motors, each 60 RPM, one chassis, one microcontroller, one ultrasonic sensor, 6 C-shaped legs, 3 relay modules, 6 shafts, 26 nuts and bolts, one microcontroller, one breadboard, 10 jumper wires, 1 screw terminal, 30 resistors, 24 L clamps, and lastly 6 motor clamps. The fabrication required for each of these have been mentioned sideways in another column, as you can see. Lastly, we have motor and battery sizing. So beginning with motor sizing, we have employed all the necessary formulae that was given to us, and we have arrived at a result that our subsystem requires 60 rpm motors. We use 6 of those, and they were the appropriate choice after arriving at the result. Lastly, we have battery sizing. So after performing the calculations, it turns out that the power that is required would be 3.9564 watts for our entire bot.
Functional specification of the entire system. For a given function of the system, the specification for each are identified here. For forward movement, the bot should be able to move in a forward direction when there is no obstacle detected by the ultrasonic sensor. Overall, there are 6 DC motors in a given system. The 3 DC motors, which are forming diagonally opposite to each other, will be moving simultaneously, and the remaining 3 DC motors will be running by the delay of about 500 to 600 microseconds. But when the obstacle is detected by the bot, it may either stop its movement or move in a backward direction. Sensing obstacle. Here we use ultrasonic sensor to sense the obstacle at about less than 20 cm from the sensing unit, as the ultrasonic sensors are particularly used to identify the distance between the sensing unit and the obstacle. Dwelling. During the forward movement itself, the bot will be able to dwell through the soil, indicating the LED light is used as an indicator when the obstacle is being detected by the ultrasonic sensor. It will be beeping at about 1 to 2 seconds. So let us start the stimulation of the entire system by using the Tinkercad platform. Here we use the 6 DC motors which will be running accordingly. Like The three DC motors, which are diagonally opposite to each other, will be running simultaneously, and the other three DC motors, which are diagonally opposite to each other, will run by giving the delay of about 600 seconds. Here we use the ultrasonic sensor, which senses the obstacle at a particular distance, and the LED, which indicates the obstacle. The Arduino board, the breadboard, and the battery is used in the entire system in order to run the system accordingly. So let us go with the stimulation part. Let us start the stimulation. When we start the simulation, the ultrasonic sensor detects the obstacle at a given distance. That is, we can see here 138.7 centimeter is the approximate distance of the obstacle from the sensing unit, that is the ultrasonic sensor, which will be able to display on the serial monitor. See, we can observe here that is approximate 138 centimeter is being displayed over the serial monitor. Now, due to which the motors are running in the forward direction. As we have given the condition, if the obstacle is identified less than the 10 centimeter or about 20 centimeter, the DC motor stop its movement and LED bulb to stops, indicating that obstacle is around less than 10 centimeter distance. So which will in turn lead to stop of the entire system at a particular point. So I would like to conclude my stimulation part by thanking you all.